So my goal right now is to make sense of what happened yesterday. And then, once we make sense of, well, and also to help kids that were gone. So yesterday, the problem was this, that I saw somebody driving 52 miles per hour on Lake Road, right out there. The mean speed was 40, I'm sorry, that should be mean, X bar, and the standard deviation was 5. Now let me really try to teach and have you understand what this means. A smaller standard deviation means that the numbers are close together. So if I would consider this a small number, if I would add and subtract 5 to this, that would mean most people were going between 35 and 45. Now let's say instead the people going on Lake Road are way different. There's a lot of grandmas and grandpas going slow, 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 and a lot of students who have no idea what the speed limit is, going really fast. And then that data, the standard deviation is how spread out, and so maybe I would calculate it to be 8. That would mean add and subtract 8, so most people would be going between 32 and 48. Do you see how that would be more spread out numbers? Shake hands if this is sort of making sense to me, okay? And let's just say that it's a really, really icy day, and everybody is going slow because it's a really, really icy day. The grandma and grandpas are going slow, and even the kids are going slow because it's a really icy day. And if the standard deviation is small, like almost everyone's going between 13 and 17 miles an hour. A small standard deviation, like lots of people are going almost that mean. Shake your heads, please. Okay, cool. So the one we had yesterday, the example was that the mean speed was 40 miles per hour with a standard deviation of 5. Anyone absent? All we did yesterday was something called a z-score. And I don't need the word score, I don't know why I just did that. And it is the data. So this person went 52 minus 40 over 5, which is 12 over 5, which is 2.4. That meant nothing to you until now. Take a quick glance at both sides of the worksheet, or not worksheet, of your data sheet. Real quick. Do they look similar? Yes. Now look closely. Are they the same? No, they're not the same. One side, the z's going down, up and down, are what? Are negatives, and one side they are positives. All right. Is 2.4 a positive number? Yes. This is for everyone here yesterday. This is about to make sense. Would you look at, please, point 2.400. So you're going to be in the 2.4 column, and then up top at 00, 01, 02, 03. So 2.400. So it's 2.4. And please tell me what that says. 0.9918. Would all of you immediately change that to a percentile? Quick. 99.18. So now, this is going to make sense from yesterday. This person driving this speed with this data was driving at the 99.18th percentile, the 99th percentile. That means if there were 100 people, 99 were going slower and maybe one was going higher. That's now what that z-score means. That makes a little sense? Okay, all right. So then the second problem was somebody lifting weights, all right? And they're at the gym, and they've got those really, really big people who do nothing but lift weights, and their whole life is just being really, really big, all right? And there's people who are fit, and there are people who are just starting. And I believe we had the mean weight that people could lift was 200 pounds. That includes the huge people. That includes the beginning people, the mean. Now, the standard deviation was 75. Okay, I really want you to understand this, okay? In our meeting, we just said, go over things with repetition. Here's what old teachers say. Duh, of course. Okay, anyways, all right. So here's what it means. Most of the people, take away 75, most of the people could lift between 125 and 275 pounds. How many have been to a gym, lifetime, experience, LA, something like that? Do we have the big people that are just big and all they do is lift weights? Do we have beginners and small people? Okay. Are there probably some people that can lift 200 pounds? Are there some that can probably lift 50 pounds? Sure. All right. So at a gym, it would be more. All right. Now, how about this? If I had all of the football players, all the football players are supposed to lift weights. I think that's part of being football. Do I have any football here? Yeah. Or no? Yeah. Okay. They're supposed to lift weights. All right. So probably the standard deviation would be a smaller number. Since all of them have been lifting weights, the amount they could do would be closer together in general. Would there certainly be some high? Yes. Some low? Make a little sense? If we're on like the whole football team, all right. Well, this example was at a gym, so here we go. And then there was somebody who could lift 300 pounds. Okay, a big strong person could lift 300 pounds. The Z-score, which everyone here yesterday was just a number. Here we go, the Z-score, anyone gone? Here's how you calculate it. The data minus the mean over the standard deviation. And I believe, did I do something? Is it 1.3 repeating? Did I do that right? Yep. Okay, cool. Would you now, on your Z-score, look for 1.3, and then there's 0, 0, 0, 1, 0, 2, 0, 3. So you'd look 1.33. Look up here if you don't know what I mean. You look up there and find 1.33. 1.33. 0.9082, say, I see that. Yep. 0.9082. Quickly, how about let's round that a bit.
Wait, why would it be the...
So we're going to go 0.13 and then over to the 3 going down.
Why didn't we do that for the last one? It was 2.4.
It was 2.40000.
Okay.
This one's 1.33333333. That's why. And 1.333 is 90.82. Rounds roughly to 91th percentile, 91st. So, this person, although unusual, if there are 100 people lifting weights, there would be about 9 people who could lift more weights and about 90 people who could lift less weights. This is still good, but is it near as unusual as that person driving that was 99.18? Shake your head that I'm making sense to you, I really hope. Oh, good, good, good. Okay, and then the final, and, all right, I'm recording this so I won't get too humorous. Are there any of you who have more than 40 cats? Okay, good, good, good. How many of you have an aunt? No, okay, never mind. Okay, all right, all right. I don't know much about cats, but I think I made up these numbers. The average cat weighs 10 pounds. Cat people, is that actually too much? No, I'm seeing a no. Okay. All right. Standard deviation of 4, meaning most cats would weigh between, take away 4 and add 4, between 6 and 14. All right. That would be most. Are there still some cats less? Are there still some cats more? And then we saw this really fat cat that was 20 pounds. So yesterday we did the Z-score, which is 20 minus 10. 20 minus 10. Divide by 4. 10 over 4, which is 2.5. Would you please look at 2.50? Please find 2.50. 2.50 is Let's look at this way. Okay, see if you can be with me. Let's look at 10,000 people. If we have 100 people, basically 99 below and maybe one above. But let's get even more precise. Ooh, let's see if we can do this out loud. Please, it is cold and flu and COVID season. Cover your mouth. This is the tenths. Come on, tenths, hundredths, thousandths, 10,000ths. So this would mean if there were 10,000 cats, approximately 9,937 cats would be smaller, and approximately 61, 62 would be bigger. And that first number we had, what was it, about 9.9, what was the first one? 9918? And you see that this is a little more out there, a little more extreme, a little more, you with me? Awesome, awesome, awesome. Oh, that was